Welcome everyone to this tutorial on optimizing Python performance with Cython. In this video, I will explore how Cython can enhance the performance of Python applications by leveraging C extensions. By the end of this tutorial, you will have a solid understanding of Cython and its benefits for optimizing Python code. What is Cython? Cython is a superset of Python designed for writing C extensions. It allows developers to add type declarations and translate Python code into optimized C code. Cython bridges the gap between Python and low-level languages like C and C++ by enabling significant performance improvements for computationally intensive tasks. How does Cython work? To use Cython, you write code in .pyx files, which are similar to Python files, but can include type declarations and Cython-specific syntax. Cython code is then compiled into C code using the Cython compiler. The resulting C code is then compiled into native machine code for execution. Next is performance comparison with Python. The primary advantage of using Cython is performance improvements. Because Cython code is compiled into C, it can execute much faster than pure Python code, especially for CPU-bound tasks. Here are a few reasons why Cython code can be faster than Python. Cython allows you to add static type declarations to variables and function arguments, which enables the compiler to generate more efficient C code. Cython also allows you to call C functions directly from Cython code, eliminating the overhead of Python function calls. Cython can optimize loops more effectively than Python, resulting in faster execution times for loop-intensive code. Integration with C libraries. Cython can easily interface with existing C libraries, allowing you to leverage the performance benefits of those libraries from Python code. Next, we're going to set up development environments by installing Cython libraries on your computer. Let's go. Now, open up your favorite code editor. My favorite code editor is Visual Studio Code, and create a directory called Cython. Right-click on the directory and open in terminal. Then, to set up the development environment, first install the Cython using pip install Cython. All right, now the Cython compiler is installed, and create a file inside the directory, like some squares.pyx, because the .pyx is the extension for Cython. That's similar to the Python extension like py. And open up this editor. Now let's define a function. All right, this is the Cython code. The use of cdef in Cython is significant because it allows variables to be declared with C stylus statically, making them more efficient than regular Python variables, because Python variables are dynamic and this is static. This is very important, especially for efficiency. By declaring variables using the cdef keyword, Cython can generate optimized C code leading to better performance, especially in computationally intensive tasks or tight loops. It is a key feature that helps us bridge the gap between Python and C by enabling developers to write high performance code with ease. All right, next I'm going to show you how to create a setup.py file to compile our Cython code. Now create a file setup.py and open up and import some modules, list utils dot core import setup, and from Cython dot build import Cythonize. Now define a setup function axt underscore modules and call the function Cythonize. Inside Cythonize, define the file name sum squares dot pyx. All right, now run this code. Python to build the C code. Python 3 setup.py build underscore axt dash dash in place. It's going to compile the Cython code and create a C code. Yeah, everything is successfully compiled. You can check out the sum squares.c code. Look at this. This is auto-generated when you compile the Cython code. And this is also the object which is compiling the sum squares.c file, because that should be compiled into bytecode. All right, next I'm going to show you how to compare the performance of the normal Python and Cython with the same function and the same input. And now let's create measure performance.py file. So to measure the performance of the Cython and Python, we are going to use time is module that is very essential to measure the execution time of the functions. All right, now I'm going to execute this measure performance.py file and see the performance of both Python and Cython code with the same input. Let's go on. By comparing the execution times, we can observe the performance difference between Python and Cython. As you can see here, the script executed each function 10,000 times and measured the time it takes. You can compare the results to see the performance difference between the Python and Cython. So the execution time of the Python in this case is 9.67 around, and the execution time of Cython is 0.089 something. So the same task with different execution times. So Cython can improve the performance of Python by adding as an extension of the C style extension. In most cases, you will observe a significant performance improvements with the Cython version compared to the pure Python version, especially for computationally intensive tasks or functions with tight loops. So this is a simple example how you can measure the performance of Cython and Python by performing a simple sum squares function with the same input. In conclusion, Cython is a powerful tool for optimizing Python performance by leveraging C extensions. Its ability to translate the Python code into optimized C code enables significant performance improvements. So I encourage you to explore Cython further and experiment with optimization in your Python projects. So this is all about today's lesson, how to optimize the Python's performance by leveraging C using the Cython extension. Thank you for watching this tutorial on optimizing Python performance with Cython. If you found this video helpful, please like, share, and subscribe to my channel for more tutorials on Python and software development.